So thank you. Welcome to the battery life presentation. My name's Stuart Harrell, and I'm going to start by giving you a brief introduction of who I am. I work at Pebble as an engineer on the firmware team. Along with that, I also spend a lot of time working and thinking about battery life and how we can improve that for our users. I also make Pebble apps. Tiny Bird about 6 months ago. It's my one Pebble app. So why might you care about battery life? Through customer surveys, we've done about 25% of customers say that battery life was important to them, and it was one of the reasons that they kept using their Pebble. And this number is probably going to rise in the future as other wearable platforms have a poorer battery life, and people who value battery life will migrate to the Pebble. In addition to that, in the future we may possibly start to tell customers about apps which hog their battery. So one way that this might possibly look is when you get a low battery notification, it might tell you the one app that consumed the most of your battery life. Sorry. And another just possible potential thing is we might start indicating battery hogs in the App Store. Lastly, the three question marks is this is my guess at why you care. It's really valuable to hear your feedback, if it's in person or through email. Your feedback is so valuable in shaping how we continue forward with battery life. So here's an overview of the talk. So the first 10 minutes, we're going to start with a guessing game to try and give you some intuition for battery life. And the next 10 minutes, we're going to go dive a little bit deeper and talk about how you can get more battery life in your particular app. In the last 10 minutes, I'm going to present an interactive demo, which will allow you to see the battery stats for your own app. So, guessing game. So the game is called Guess the Battery Life. First, I'm going to present a scenario to you all. I'm going to ask you to then put on your thinking face, take a couple seconds to ponder the scenario and what its battery life will be. And then I'm going to ask you to hold up either 1, 2, 3, or 4 fingers to indicate your guess. And lastly, I want to emphasize that this is not a competition. I want you all to be yourselves, and together we can learn together and get ourselves on the same page. Okay, so let's start with a practice round. So on the right, you can see a watch face that updates on the minute. You might recognize it as simplicity. So I'm going to ask you to take a few minutes to think, and once you're done thinking, raise your hand. And if you think the battery from full charge to empty will be less than 2 days, put up a 1. If you think the battery life will be between 3 and 5 days, hold up a 2. Between 6 and 12 days, hold up a 3. And if it's more than 12 days, hold up a 4. So I'll give you a few seconds to think carefully.
Is that an airplane mode?
Not in airplane mode. And this is also without notifications and without any Excel taps.
No notifications?
No notifications. Okay, thank you. So the answer is 4. You will get more than 12 days. And in practice, you'll get about 14 days of battery life. Okay, so let's continue on through a few more of these scenarios. Okay, next, the backlight is on constantly, and it's sitting in the same watch face. Thank you. So the answer is 1. You'll get less than 2 days of battery life. In practice, you'll get 4 hours of battery life. So next we have a watch face with that updates on the second. So you can see on the right is simplicity, but instead of updating on the minute, it's updating on the second. So take a moment to think, and please raise your hands when you're ready. Thank you. The answer is 3, between 6 and 12 days. In practice, you'll get about 9 days of battery life. Okay, next, a watch face that also updates on the minute, but it has an animation on the minute. So you might recognize this as the text built-in watch face. So take a minute to think and raise your hands when you're ready. Okay. The answer is 3. You'll get between 6 and 12 days of battery life. And in practice, you'll get about 11 days of battery life sitting on text. Okay. So here again, we have a watch face that updates on the minute. It's a simplicity. And this time, Bluetooth is off. It's in airplane mode. Thank you. The answer is 4. You'll get more than 12 days. You will get 36 days of battery life with Bluetooth off in simplicity.
Did you actually run that for a month?
No.
No, I ran watch with Bluetooth off. Nothing special for I ran 20-something, more than 20-something days, close to something.
Oh, well, thank you for it's an interesting data point. Yes, the gentleman commented that he ran a similar watch face, and it lasted more than 20 days with Bluetooth off. Okay. So next, we have a watch face with a constant animation, just a rotating house, and it's rotating at 30 frames per second. So take a minute to think, and please raise your hands when you're ready. Okay. The answer is 1. Very good. You'll get less than 2 days of battery life. In practice, about 1 day. Okay. So now we have a watch face that's grabbing the weather once per minute using that message. Take a moment to think, and please raise your hand when you're ready. The answer is 3. Between 6 and 12 days, you'll get 6 days of battery life in practice. Okay, now similar scenario. Instead of grabbing the weather once per minute, you'll be grabbing it once per second. Very good. The answer is 1. You'll get less than 2 days of battery life, and in practice, it'll be about 18 hours. So thank you for going through that guessing game with me. Hopefully it gave you some broad framework within to think about battery life and how different system components affect it. Here, I just want to go through it once more to sort of solidify it in your minds in case you missed any of them. We saw that if the backlight was constantly on, you'll get about 4 days of battery life. If you're doing a constant animation at 30 frames per second, you'll get 1 day of battery life. Bluetooth, when you're using Bluetooth on the minute, you'll get 6 days of battery life. When you're using Bluetooth on the second, 18 hours of battery life. And when it's turned off, you will get 36 days of battery life. Next, for the tick timer, if you're sitting on a watch face that updates once per minute, simplicity in our example, it'll last 14 days. And if you're sitting on a watch face that updates on the second, you will get about 9 days of battery life. Okay, thank you. So now the next segment of this presentation, we're going to be diving a little bit deeper. It's some tips and tricks that you can improve the battery life for your own particular app. Yeah.
Background apps. The background apps that you guys are providing now.
Yes. If you're running Misfit, the gentleman asked about background apps and their impact on battery life. So it's a very good question, by the way. If you're running a background app, it varies from background app to background app. But if you're running Misfit in the background, it will, if you're getting 5 days of battery life without Misfit, it will go down to 4.5 days with Misfit. Okay, so next segment of the presentation. So I want to introduce the concept of batching. The two biggest power hogs on the Pebble are the CPU and the Bluetooth chip. Every time the CPU wakes up, it has a system upkeep cost. So you want to wake it up as little as possible. And so that means if you can batch your computations all together rather than doing them more spread out, you will save on battery life because you'll be saving on the system upkeep cost every time you turn on the CPU. Analogously, for the Bluetooth chip, every time it wakes up, it has to open the communication channel and remain in a high power active mode for a short time. So every time you turn on Bluetooth, there's a cost associated with that. So if you can send all of your Bluetooth messages together in a batch, you will save a lot of battery life, and we'll see that in a second. Okay, so batching Bluetooth usage, just some example numbers for you all. If you're sending an app message on the minute, you will get about a 6-day battery life, as we saw earlier. And if you're sending an app message on the second, you will get 18 hours of battery life. But if you choose to batch your Bluetooth calls and send 60 app messages on the minute, you will still get 6 days of battery life. So in the last two cases, you're sending the exact same amount of data, but if you batch them, your battery life will improve significantly.
How close together do you have to put the messages to get that sort of acting? What will keep the Bluetooth radio on so you're not having a shutdown? Like, you put them like a second apart, does it shut down, or is it like, a tenth of a second? What sort of time frame do you need to
The gentleman asked, what sort of time frame does the Bluetooth chip stay on for each Bluetooth message? I'm not quite sure on that. I can't tell you off the top of my head, but it's definitely less than a minute.
Yeah, okay. So you can't do 60 app messages. You have to stack them up together, right? You can't sort of like just spread them out at some distance, and then at some point it's going to eventually shut down. If I don't answer it, you know if there's like some optimization there.
Okay. So yeah, just to recap, the gentleman asked if there's some like optimal length between app messages.
No, so what's the window?
The-
Batch everything together, you're going to get it in that one moment when it's up.
Okay.
Once you win it, it's going to shut down, and then if you queued it, you have to reactivate everything.
I see. So his comment was that we want to track what is the window for which the Bluetooth chip stays in active mode. Did I get that correctly? So I don't know this for sure. I think it's 45 seconds. But let me follow up with you afterwards on that, if you like. Okay, so that was batching Bluetooth usage. And next we're going to see if we batch accelerometer readings. So when you're using the accelerometer, there's sort of two things you can control. You can control the frequency at which you're sampling, and you can also control the number of samples you take before you wake up the CPU and process them. So some hopefully descriptive numbers for you all. If you're running the accelerometer at 100 kilohertz or at 100 hertz with 25 sample batches, you will get about a 12-day battery life, so it's a very small impact. Whereas if you're running at 100 hertz with 1 sample batches, that'll go down to an 8-day battery life. And so these numbers are when no processing is occurring. If you're doing FFTs every time you process, these numbers are going to go down as you do more processing. And I want to emphasize that the accelerometer cost, running the accelerometer costs very little. It's waking up the CPU that has the big impact on your power consumption. Okay, next we're doing animations. So the frames per second of your animation matters. So we saw earlier that if you have a rotating house at 30 frames per second, you'll get about a 1 day battery life. And next, if you change the FPS to be instead 10 FPS, you'll increase to 3 days of battery life. So sort of a general theme in these slides is that you have a decision between, you have to decide, will your users value more battery life, or will they value, in this case, smoother animations? So you have to look at your own particular application and make that decision. Okay, going on with animations, vertical versus horizontal animations. So if you're flashing on and off a 1 pixel row at 30 frames per second, you'll get about a 5-day battery life. Whereas if you're flashing on and off a 1 pixel column at 30 frames per second, that goes down to a 1-day battery life. So a huge difference. Why is that? It's because our display draws row-wise. So if you're updating just a single row, then the display just has to draw that one row over and over. But if you're updating the column constantly, the display has to update all 168 columns constantly. So if you plan on having a long-lasting animation in your app, consider minimizing the number of rows that change between each frame in the animation. Okay, second versus minute watch faces. We saw earlier that if you run simplicity that updates and it updated on the minute, then you'll get 14 days of battery life. And we also saw that if it's updating on the second, that goes down to 9 days of battery life. So I just wanted to emphasize that these are the tick timer calls. If you use the minute call, your battery life will improve, whereas if you're using the second call, you'll be waking up the CPU more and possibly drawing more too. So the power consumption difference between these is it's a mix of if you're updating on the second, then you're waking up the CPU more, and if you're also drawing more if you're drawing every second. Yep.
The main difference is the waking the CPU or it's drawing the screen?
That's gonna.
The combination.
The question was, I said the power consumption is a mix between waking the CPU and drawing to the display. The gentleman asked, what does that proportion look like? So in general, this is going to be dependent on your particular app. Like if you're doing if you're doing fancy draws on the minute, if you're updating the whole screen on the second. Sorry, if you're drawing to the whole screen on the second, that's going to be different than if you're just drawing to a couple rows on the second. But to give you sort of intuition for simplicity, simplicity drawing to the display consumes more power than the CPU. Yes. Did that answer your question? Thank you. Okay, next, don't leave on the backlight. We saw earlier that leaving the backlight on will drain a fully charged battery in about 4 hours. So be careful when you're using our light enable API call. Always, if you do use this call, please take a minute and think, is this really necessary for my app? And if you do decide to do it, please consider giving users the choice of whether they want to keep the backlight on or not, so that the user can decide how much they value battery life, and then they can choose, do I value more battery life versus maybe the improved user experience from having the backlight on. And finally, don't repeat my mistake. In TinyBird, I was like, I thought, oh, you leave the backlight on, and it makes the app look so much better. It makes it look so much clearer to play. I've changed that, but please learn from my mistakes. Okay, just give you a summary. For the backlight, you want to avoid using light enable. If you're doing animations, consider experimenting with lowering the FPS, the frames per second. and also consider trying to minimize the number of rows associated with the animation. For Bluetooth, please try to batch calls that use Bluetooth whenever possible. And for the accelerometer, try to process data in larger batches. It goes up to 25. And if you do this, your CPU will wake up less often, and you'll save on power consumption. And finally, for the tick timer, waking the CPU every second is more expensive than waking every minute. Okay, so now I'm going to present a sort of interactive demo. So the purpose of this demo is sort of to allow you to see the battery statistics for your own app and possibly see things that might be improved. So let me walk you sort of through what this tool is showing you here. So this is for the dots watch face by Wukas, who's also here. You'll see in the top graph here, on the x-axis is the battery percent drain per hour, and on the y-axis is the number of hours that this drain occurred. So how to interpret this, you can see for dots, almost all of the hours, the battery percent drain was less than 1%, and hovering around 0.5% to 0.75%. And so that gives you how much, I guess, power consumption your app is using. And also, if you want to improve on that, we also show you the power consumption by system component. So dots is a pretty good example. There's not terribly much it can improve, but it shows you how much power the Bluetooth chip consumed, how much the CPU consumed, backlight, and drawing the display, and how much the vibrator consumed. And also on the left, you can see usage by system component. So you can see you see how much you used, for example, the CPU, and then to the right, you can see its impact on battery life. So so dots is pretty boring. Let's look at TinyBird. So TinyBird, you can see it's worse, and you can see that the reason for that is largely the backlight is on, and the backlight is eating up a huge chunk of the power consumption for TinyBird. One more example. Here's Simplicity, the built-in watch face. And it's pretty analogous to dots. So if you want to look at a good watch face, Simplicity is probably the ideal to go by. Okay, so now it's your turn. I've provided the link to this tool, so you can open your computer, visit the tool. You can look at the power consumption for any popular app. And so we realized that some people might not wish others to see their battery data. And if you wish to hide your battery data, please go to this tool and you can input the UUID of your app, and it will delete it from the tool so others can't see it. Okay. And with that, that's the presentation. Thank you all so much for listening. Questions?
Yeah, as an option for like the regular consumers, did you guys consider turning the shake to light off when the product ships? Because I think my friend was jogging with it and he was saying my battery just died in like 4 hours. I was like, well, that's really weird. I could like never figure it out until now.
Excellent question.
Probably just kept that option like untouched.
Yeah. So the comment was, have we considered perhaps making shake to light default to off? And the answer is yes. As you pointed out, people jogging, playing squash, spiking. This is a common problem, and we're working to address it. Yes?
There are some backlight options right in these settings. Do this override the API calls? If I say I want the light enabled, but in this setting it's turned off or it's ambient only, the automatic mode, does it affect that or it will be just on?
I'm fairly sure it will be just on. So the question was, in the settings, there's 3 options for your backlight. It can be on, ambient, or off. And the question was, does light enable respect these backlight settings? And the answer is no, I believe.
And can we access the settings? We can, right?
Not at this time, no. Yes, sir.
Along the lines of that, so I have a use case where the backlight turning on isn't quite long enough. So it would be ideal if there was a way of being able to flip it on for 5 seconds. And I know you can do that with the enable on and off.
Mm-hmm.
The on part's easy, but the off part kind of requires, you catch all the cases where your window leaves, blah, blah, blah. So it would be helpful to a convenience function to let something turn on for 5 seconds.
Thank you. The comment was, it might be nice to offer a convenience API function. So we have enable light interaction, which turns on the backlight for, I think, 3 seconds and turns it off. And the comment was, it might be nice to offer a sort of syntactic sugar so that you can specify the time that the backlight turns on and off. Thank you. That is something to.
The default's a little bit too short for some cases.
Okay.
Like for driving, for example.
Thank you. Yes, sir.
An idea that I've seen discussed a little bit recently on the forums is the idea of a sort of ultra-low power mode for Pebble. So perhaps on the 10% warning, you have the option to activate only simplicity and have that be stuck essentially. What are your thoughts on implementing something like that? Because at the end of the day, it is a watch. So if it runs out of battery, it's good.
The question was, have we considered sort of when the watch reaches some low battery percent, turning it into just a watch, so to extend the battery life? That's an excellent question. You might expect a feature like this very soon. Okay, so the feature is, and I would love feedback on this. Right now, the current plan is when the battery reaches some very low percent, perhaps 5%, it will go into all the buttons will be disabled, and it will just show just the time and perhaps the date. And there will be no notifications, no running apps, and in this mode, you might expect to get somewhere between 2 and 5 additional days of battery life out of your Pebble.
Wow.
Okay. Thank you for the great questions, everyone. I'll be migrating over to the workshop room, and I'll be there to answer any questions you might have for the next 30 minutes.
One more question.
Yes, sir.
From user point of view, okay, this is for developer, but user point of view, the classic question about when to charge a Pebble. I mean, from what I saw, it's like it makes more sense to charge it somewhere around, let's say around 30% every few days. Is there kind of common guidance? Because I've never seen any.
So the question was, and I'll be very quick with this, is there some best percent to start charging your Pebble at?
Kind of like charging policy. Like, what is the best method? Because some people think it's best to charge every day, so it will be always full. Which, as far as I know, it's actually not really ideal. But,
Can I dig into your question a little bit more? And are you asking from the perspective of extending the lifetime of your battery?
yes. Yes.
Okay. Excellent question. Pebble, we use a lithium-ion battery. So it doesn't matter when you charge it. If you charge it at 10% or 90% every day, that will have no impact on the lifetime of the battery. The lifetime of the battery depends only on the total percent of the battery that you've discharged over its lifetime. Did that answer your question?
Actually, I'm not so sure if it's true because I think, for example, if you leave the battery empty for a long time, it's actually not so good.
Yes, sir. Okay. That is true. For lithium-ion batteries, you don't want to leave it at 0% for a long period of time, as that will mess with the battery. The battery's chemistry will start to eat itself, and it will the full capacity of the battery will decrease if you leave it for a long period at 0%.
Or at 100%. Not too full, not too empty. Don't store it too full, don't store it too empty.
Okay, there you have it.
Story just right. The Goldilocks problem.
And I was told to tell you all that your Pebbles battery should last between 3 and 5 years under normal discharges. So I'm being kicked out. So thank you, everyone. I will be in the Q&A room.